Math 3, Unit 4 final review. So today we're talking about radicals and simplifying radicals. So the one thing that you need to remember is that when you have an even root, and what do I mean by even root?
Like 2.
Right, like 2 or 4. So like this right here, if it doesn't say it, it's an even root. This is 2, but this is an odd root. Okay, so when you have an even root with an even exponent.
Just a quick reminder that the impact meeting will be starting at 7:15 in the library annex.
With an even exponent in the original problem, you will need an absolute value if the exponent comes out odd. This probably should have been a colon. Okay. Do you guys have all that? So here on this first example, if you look at the exponents, are there any even exponents in the original problem? No. So we don't have to worry about absolute values. Okay? So this is where we're just going to break it down, and you need 2 for a group in order to be able to pull something out of the root. And so what 2 numbers multiply to be 72?
36 and 2.
Okay. I'll go with 8 and 9. You could do anything that you want to. Okay, and then I know that 8 breaks down to 2 and 4. I know that 8's just 2, 2, and 2, so I'm just going to put it as 2, 2, and 2 instead of doing a whole bunch of different factors. And then 9 we know is 3 and 3. And so I have a pair of 3s, I have a pair of 2s, and then anything that's left over, I like to box it to remind me it's going to stay in that root box. Okay? Now with x to the 5th, again, we need 2 for every group. And so I'm just going to write these in groups of 2. So I have x squared, and then x left over. So I have 1 group, 2 groups, and then 1 x left over. And that all adds to be 5. And then for my y, we're going to have a y squared and then a y left over. Is that good? Okay. And so anything that's brought out gets multiplied together, and anything that's left inside gets multiplied together. So we have 2 times 3, which makes 6. How many x's do I have? 2, because there are 2 groups, right? So that makes x squared. I only have 1 y, so we write that as y. And then under the root, we're left with 2xy. And so this ends up being my final answer. Okay, any questions there? Okay, you'll notice the next one, the root is what? Cubed. It's a cubed root. There's 3. Okay, is that an even root? No. So we don't have to worry about absolute values here either. Okay? So what I would do is, because these are multiplying, I end up writing all of them together under one root. So what do I mean by that? So I'm going to do the cubed root. Now 36 and 120, I'm going to end up breaking those down into my factor tree, and so I don't usually multiply those together. I just write them as 2 numbers, almost like I'm already doing my factor tree. So I have 36 times 120. Now when it comes to the letters, I like to just write them together so that I'm not dealing with 2 separate things. So m squared and m would make m to the 3rd. And then n to the 5th and n to the 2nd will make n to the 7th. Okay, and then I'm going to go through and start breaking down. Now, this time, instead of 2 to a group, I need 3 to a group. Okay, 36 breaks down to what?
66.
Okay, I have 2 6s right now. Now, while I could break these down to 2s and 3s, Is there any way of making 120 so that it breaks down, it has a 6? What would it be? Good, 6 and 20, right? Are we good with that? And so I'm going to stop there. I could break those down and get a group of 2s and a group of 3s, but it's unnecessary. If you have a group of 3 of the same numbers, then circle it and stop there. Now 20, is there any way of breaking that down so I'm going to get 3 of a certain number? No, because 20 is 4 times 5, right? And then 4 can break down to 2 and 2, but that's not going to give me 3 of anything. So if it's going to waste your time, don't break it down unless it's going to help you, okay? If you look here, we need 3 for a group. I have 3 M's, so all my M's are in a group, and I'm good there. And then end of the 7th, how will I end up writing that?
2 9 and 1.
Good, so we have end of the 3rd, and then 1 N left over. So when we write this, we're going to end up with 6 M, N to the 2nd, and then we're going to write our root. Don't forget that you have the cube, okay? And then what's left over inside? 20N. And that's it. That's my answer. Okay. Any questions there? All right. Next one. These roots now are square roots, and they also, in between them, are adding. The only way to add roots is for them to be the same. Right now, underneath these roots, are these the same? No. So we're going to simplify each of them separately, and if they end up becoming the same, we can add them together. If they end up being different, then we can't add them together. Okay? So 20. 20 breaks down to 4 and 5, and 4 is, so I have a pair of 2s, 5 left over. The x's, what's going to happen there? We're going to get an x squared group and an x left over. So when I bring these out here and there's already numbers in front, what do we end up doing with them? Multiplying them together. So I'm taking out a 2x and there's already a 3x out in front, so that's going to end up becoming 6x squared root, oh, and I forgot to box this one. Root what?
Root 5x.
Good, root 5x. So far so good? Okay, so now 45. What does 45 break down to be?
9 and 5.
Good. 9 and 5, and then 9 is 3 and 3. So pair of 3s, 5 left over, and then x to the 5th. How are we going to break that down?
X squared times x squared x.
Good. Okay, so when we write this down, there's nothing in front of this one, so we're just going to put everything that we have together. So that's going to be
3x squared. Root 5x.
perfect. So you'll notice now that both of the roots are the same. You'll also notice that the x squareds in front are the same. And so since they're all like, we can add them together. And so we are just adding. What is 6 plus 3? 9. So we get 9x squared root 5x as our answer. And again, if you went back to the original problem, do you see how you have an even root, but there's nothing even underneath here? So we don't have to worry about absolute values. Yes?
So you always add like the numbers in front?
Yes.
Just those?
Mm-hmm.
So it's kind of like the denominator.
Mm-hmm. Exactly. Like they have to have like denominators have to have like roots. Yes. Okay. So we have these equations with roots. You know how a squared term is a parabola where we have our curves? It's the U-shaped graph. When you have a square root, it's half of a parabola. And the reason why it's only half of a parabola is why? Who remembers? Because you can't have negatives under a root, right? It becomes imaginary. And so when you have a square root, when you're graphing, it's only half of a parabola, and it's actually half of a sideways parabola when you have a root, okay? So this right here, if you're looking here, there's nothing with the x, so that gives it a 0, and then there's nothing being added at the end, so it's another 0. So it's a 0, 0, okay? And then we talked about how to find the other points on the square root graph. It's easiest to plug in numbers. Like if I plugged in a 4, square root of 4 is 2. And so I could go right 4 up 2, make a point, and then that gives me, when I have 2 points, I can make my graph. Okay? Remember too the shifting. Okay? And so if you have this function and you're adding a c value at the end, it's going to shift up. And then if you have a negative c, it's going to shift down. And then when it's inside with the x like that, it's going to shift left, and then negative c inside would shift right. Okay, and then dilation of x multiplies each value of the function by a, where a is a constant value. Or again, like we talked about, you can just plug in values if you wanted to. Okay? All right, so let's go ahead and sketch these graphs, and then they want to know the domain and range. Okay, so first one right here, what would be the vertex? 1, comma, negative 5. So we would go right 1 and down 1, 2, 3, 4, 5. Okay? For graphing this, because we know it's going to be a sideways parabola, you know, it's going to end up going this direction. Do we all agree with that? So the most important point I would say that we need to find would be my x-intercept. Exactly. And so let's find our x-intercept. How am I going to do that? Good. 0 for y. So we have 0 equals 3 root x minus 1 minus 5. So again, we're plugging in 0 for y, and we're going to solve for x. What do I do now?
You add 5.
Okay. So I have 5 equals 3 root x minus 1. What would you guys do next? Okay, we can do that. Divide by 3 to both sides. So I have 5 over 3 equals root x minus 1. Now what? We're going to square it. Good. So we square it in order to eliminate the root. Correct? So we square both sides. So 5 over 3 squared, what's that going to become? No. 25 over 9 equals x minus 1. Now, you could leave this in fraction form, but when I'm plotting this on a graph, I'm going to want it as like a number, right? So you could use your calculator even and just divide 25 divided by 9 to get what that is as a decimal. And so I would just round it to about 2.8. Does that sound okay? So we have 2.8 equals x minus 1, and then to solve for x, we just finished by, good. And so what does x equal? Perfect. And so now we know our x-intercept, so we're just going to go to 3.8, make a point. And now that you have those 2 points, you can just make your sideways parabola there. Okay, so based on that information, now we need to state our domain and range. So domain is always dealing with the x's. And so what is our smallest x value? Good, 1. Does it equal 1? Yes. Because there's an exact point there at 1, right? So it's not like the asymptotes how we have on some of the graphs. This has a point at 1. So am I going to use a parenthesis or a bracket? Bracket. So we have a bracket at 1. And then on the x-axis, it goes all the way where? Positive infinity. Good. Okay, in infinity, we always use a parenthesis. Okay, range. What's our smallest range value?
-5.
Good, -5. And does it equal -5?
Yes.
Yes, so will I use a bracket or a parenthesis?
Bracket.
Good. And that's at -5, and it goes all the way till positive infinity. Okay? Is that good? Questions? All right, so let's move on to the next one. Is there anything you notice about this one from the last one? Good, there's a negative in front, isn't there? Do you remember what's going to happen when you have a negative in front like that? It's going to end up flipping. So you know how our original graph is curving up like this? When you have a negative in front, it is reflecting it over the x-axis. And so it's going to end up curving down. Okay? Does that make sense what I'm saying? Okay. But if we plug in points, we should be fine with figuring out what's happening, and it should end up showing that reflection over the x-axis. Okay, so what is going to be my vertex on this equation? Good. And so we go left 3, and then up 4, and make our point. Okay, so where do you think is going to be another point that we're going to want? We want to find our x-axis again, right? We want to find the point it's going to cross the x-axis. Because if this was a positive one, it'd be curving up and there wouldn't be an x-intercept. But since it has a negative in front and it's curving down, we know there's going to be an x-intercept. Okay? And so, again, how do I find my x-intercept? Good. So our x-intercept, we're going to plug in 0 for y. So we have 0 equals negative 2. Maybe didn't give myself enough room. Root x plus 3 plus 4. Okay, what will I do first? Good. Subtract 4 to both sides. This cancels. Negative 4 equals negative 2 root x plus 3. What will I do next? Good. Divide by negative 2 to both sides. That cancels. Negative 4 divided by negative 2 is 2. So now I have 2 equals root x plus 3. Good. Square both sides. 2 squared is? So 4 equals x plus 3. And then what will I do? Subtract 3. And so my x-intercept is 1. So we'll go on the x-axis to 1 and make a point. Okay, there will also be a y-intercept. Will it matter what the y-intercept is? No. Because it's not going to give us like our minimum or maximum value, okay? And so the y-intercept doesn't really matter. We could find it, but I'm just not going to worry about it. And so this gives us an idea of what the graph should look like. Okay? So now domain. Domain is our x values. What is our smallest x value? Good. Bracket or parenthesis. And it goes all the way till positive infinity. Now on the range, this one's going the opposite direction. What is our smallest value on the range? Very good. It is at negative infinity. So it's going the opposite direction, right? So the smallest value will be negative infinity, and our largest range value will be at 4. And will that be a bracket or a parenthesis? Bracket. Okay? Yeah. This is, see how this is going down? If this went on forever, it would keep going down on the y-axis. So it's going down this way, and down here is negative infinity. Just like how on this one, now it's curving up. So on the y-axis, it's going up to positive infinity. Because this one's curving down, it's going down to negative infinity.
So what's
Domain isn't negative infinity, domain is positive. Is that what you're asking me?
Yeah.
So this one, it's going, on the x-axis, it's going right to positive infinity. But on the y-axis, it's actually, the smallest value is down here, which is negative infinity. Okay, so you're looking at it 2 different ways. We're looking at it up and down for the range, and then we're looking at it left and right for your domain. Is that any better?
Yeah.
Okay. Any other questions before we move on here? All right. Go ahead and flip that over here. Okay, we need to find, it says solve for the x and y intercepts. Okay, we've been doing a lot of this. Remember that when you have a function, that really is y there. If We are solving for our x-intercept. What am I going to do? Good. So x-intercepts, we keep x, you plug in 0 for y. So 0 equals 2 root x plus 9 minus 10. Okay, what will I do now? Good. Add 10 to both sides. 10 equals 2 root x plus 9. What will I do next? Good. Divide by 2. We have 5 equals root x plus 9. What will I do? Good. Square both sides. Okay, and so I get 25 equals x plus 9. My last step would be to subtract 9, and so my x-intercept is 16. And so as an ordered pair, I'd write that as 16, comma 0. Okay, how will I find my y-intercept? Good. Y-intercept, we plug in 0 for x, we keep y. Okay? So y equals 2 root 0 plus 9 minus 10. What is 0 plus 9? 9. What's the square root of 9? 3. And so we get 2 times 3, which is 6, and 6 minus 10 equals negative 4. So my y-intercept as an ordered pair is 0, negative 4. Okay, any questions there? Okay, on the next problems, it says solve the following equations for x and check for extraneous solutions. Okay, extraneous solutions will probably end up giving me a what? It's basically going to just either a negative under the root, or it just won't equal what it's supposed to equal. Okay, so all it means is once you get your answers, plug them back in to check to see what happens. Okay, so in order to solve this one, do you guys know what you would do first? Subtract 30. Yeah. You can't subtract 30 minus 7 because that negative 7 is connected to the root. Okay, and so it's totally separate. So you would subtract 30 first. So we have negative 7 root x plus 9 equals, good, negative 28. Then I will, good. So we have root x plus 9 equals positive 4. Good. At this point, too, you would look to see, does this equal a negative, right? Okay, now what? Square both sides. And so I get x plus 9 equals 16. And then the last step would be to, and we get x equals 7. Okay? So when you're checking for your extraneous solutions, all you're kind of doing is plugging this answer back in here to make sure it works out. So I'm just going to go ahead and check it kind of quick. We have 30 minus 7 root 7 plus 9, and we're seeing, does that equal 2? What's 7 plus 9? 16. Okay, what's the square root of 16? 4. So I have 30 minus 7 times 4, 30 minus 28, and it does equal 2, so it checks out. Okay, let's go over here to this other one. What am I going to do?
Add 6.
Good. Add 6 to both sides. Okay, the root is now by itself, and so I have x plus 6 here. Now what am I going to do? Good. Square both sides. Okay, when I do that, I get x plus 12 equals, and when you square x plus 6, you can either do like your box method or FOIL method. In my head, I can do this. So I get x squared. I'm going to be adding 6 and adding 6, which would make 12x. And then 6 times 6 makes 36. Okay? In order to solve this, because I have an x squared term, we're going to end up needing to factor, which means it needs to be set equal to 0. So I'm going to subtract x and 12. Okay, and I end up with x squared plus 11x, and 36 minus 12 is 24. So what multiplies to be 24 and adds to be 11? Good job. Okay, x plus 8, x plus 3 equals 0. And when you set each of those equal to 0, what does x equal?
-3 and -8.
Good. X equals -8 and x equals -3. Okay? Now, most of the time when you get two answers, one of these answers is not going to work. Is it always the case? No. But this is why it's important to check for extraneous solutions. So let's kind of check these out here. So starting with -8, I take the square root of -8 plus 12 minus 6 equals -8. And again, we're checking to see, does that actually equal that? -8 plus 12 makes 4. Okay, and the square root, so this is going to end up becoming the square root of 4. The square root of 4 is 2. Is 2 minus 6 equal to -8? No, that does not equal. So I'm going to cross out -8. Now, since I found that -8 doesn't work, there's probably a really good chance -3 does work. But you still want to check it to be safe. So, square root of -3 plus 12 minus 6 equals -3. What is -3 plus 12? 9. What's the square root of 9? 3. 3 minus 6 equals -3. Checks out. We know that -3 is the correct answer. Are we good? Okay. These last ones. Okay. Given the following functions, perform the operation. Okay, so they've told us here is f of x, here's g of x, here's h of x. Okay, f minus g of x. All that means is we take our f equation and we subtract our g equation. Okay, so writing this out, I have 3x squared minus 2x plus 1, that's my f equation, minus my g equation, 5x minus 7. The one thing people forget to do most often is what? Distribute. And so you need to make sure to distribute that negative through. So I end up with 3x squared minus 2x plus 1 minus 5x plus 7, because two negatives make a positive. And then all you have to do is combine your like terms. So my final answer ends up being 3x squared minus 7x plus 8. That's it. Are we good there? Okay, who remembers what to do with the f of g of 1?
You plug in 1 for x in the g equation.
Good. 1 for x into the g equation. So that means I have 5 times 1 minus 7. What's 5 times 1? And what's 5 minus 7? Okay, -2 is not my answer though, right? So what that means is g of 1 is -2. That gets canceled out and we put a -2 there. So that means I'm actually finding f of -2. Okay, so now that means I'm going to go to the f equation and plug in -2. So we have 3 times -2 squared minus 2 times -2 plus 1. What is -2 squared? Positive 4. And so I have 3 times 4, which is 12. -2 times -2 is a positive 4. And then plus 1. And we add that together and we get,
17.
so my answer is 17. Are we good there?
Wait, so that's like your answer, that's what you're saying?
Yep, there's only one answer. So it's like a 2-step process in order to get to the answer. Okay, last one. It says h of g of x. So that means we start by plugging x in for x in my g equation. So my answer for g of x is just 5x minus 7. Like we're replacing x for x. So, and does this make sense? That g of x is 5x minus 7, right? So the first step doesn't actually take any work at all, and this g of x ends up getting canceled out, and we just have h of 5x minus 7. Because g of x is 5x minus 7. So now, in my h equation, I'm replacing x with 5x minus 7. So that means we just have root 5x minus 7. There's nothing to simplify, nothing you can do. That is it. If you could simplify it, you would. Okay, questions?